part for it is that, well, finals are in a couple of weeks anyway. Finals all multiple choice. So what's that? Yeah, it'll be the last test because when we start chapter 4, it's some of the trig stuff. And we'll start and just kind of get through like radians. There's only like, I was looking at it earlier today, and in chapter 4, there's going to be about 3 things maybe out of the first 3 sections. I think it's all we're going to be able to cover before final, maybe 2 sections. So there's maybe only like 2 or 3 new things that you guys haven't seen before with trig. Everything else is just, you know, how do you convert from radians to degrees, degrees to radians, how do you work some stuff off the unit circle. Nothing too crazy to start. We're not going to be going into the full right triangle trig stuff. I don't think we're going to get that far before final. So that'll happen second semester when we go back and do all that. But what we're looking at for tomorrow, it's still going to be calculator and non-calculator. And what we've done is, instead of doing like, you know, a Scantron with it, I actually just made a little answer sheet. So you guys will just put in all your answers on there. I will say that there is one question. There's only one question on the entire test that's not multiple choice. You just have to write your value, whatever the answer is for that one. Thanks, sir. Yeah. So, but we'll do like.
I thought you were going to pull the chair out from under you. No. That would be funny.
So, we'll do the non-calculator part first, then we'll just go to the calculator at the end. It's, what is it, 25 total questions, I think. It's a good mix of everything we've done. There really shouldn't be anything that'll scare you whatsoever.
That's what you say all the time.
Well, it's true though. What's up?
So like, are you still gonna do like
I don't know how. I haven't figured that part. I haven't figured that part out yet.
You got the answer on the entire question.
I haven't gotten that part yet.
What if
the guys. I haven't gotten that far yet. So the idea of, you know, let's say there's always one completely wrong answer, and there's obviously one right answer. The other 2 are the ones where you make the dumb mistake. So, but we don't weight finals. It's right or wrong. You know what I mean? Mm-hmm. So it's kind of, we look at it that way too.
What does that matter?
Yeah. You're walking into something you don't know all about. Tomorrow it's all multiple choice, so that's what we're talking about.
Oh, I'm sorry.
That's okay. That's fine. The
Is it all multiple choice?
Dude, where's
Except
your
for
bag?
one.
But like,
Is
no,
it all
like,
calculator?
all of it.
No, except for one question.
Final.
No way.
She's been driving around in a Jeep in her mind.
Texting.
Is that going to also pursue like graphing?
Yeah.
Which is the right graph?
Pretty much. Where's an asymptote, things like that. When I think about the modeling stuff that we had, the weird models were the last bunch of these word problems you guys had. They gave you some model, and then you had to try to solve out of it. The only ones that you really have to still remember how to create on your own then really are going to be your compounding interest style problems. If it's compounding monthly, continuously, quarterly, things like that.
Do we still get a note card?
Yeah, I gave it to you the other day.
Yeah. Oh, can I have one like this?
Oh, you weren't here. I'm out of it.
I had an extra one, but I really didn't have.
So you could have
Well,
shared
I
it.
mean, somebody asked for one.
No, it's fine.
Didn't have one.
But yeah, other than that, I mean, what I plan on doing today is just kind of going through a couple of questions out of the review itself, and just kind of working with you guys and see if there's anything in particular you wanted to double check, style problem or something like that.
Chandler, are those your comfortable?
Yeah,
I think we should get like a piece of paper.
So let's start taking a look at some of these review problems. Did anybody else lose one? They need one still?
I did too.
No. Here you go, Stinky.
Can I check somebody again?
Well,
I had enough room to fit everything in here. Tessa?
Wait, can you do a problem like from the home?
no, I can't do any problems. Which one did you want to look at?
50.
Hit the wrong button, that's why.
Wait, for real?
Yeah.
After this,
So I screwed something up, I know.
after discontinuing all advertising for a toolkit in 2000, the manufacturer noticed that sales began to drop according to the model. Blah. Where S represents the number of units sold and T equals 0 represents 2,000. In the year 2004, they sold 300,000 units. Solve for K. So what happens first of all, you're substituting in 300,000. Sure all my zeros, equals 500,000 over, bless you, 1 plus 0.6e to the k. And our t, well, how much time elapsed between 2000 and 2004? 4 years. Cuatro años. Okay, bueno. Sí, señor.
Is the review like you're gonna give us like a package?
No, this is the problems already on the worksheet.
You got a worksheet?
No, I'm trying to worksheet, the assignment sheet.
Oh, okay. Oh, okay.
So, in this case here, what we're going to solve for is k. Real quick trick that you probably forgot. Isn't that fraction equal fraction?
Yeah, I did that right.
Cross multiply. You get fraction equal fraction, guys. You're going to get 1 plus 0.6e to the 4k divided, or excuse me, times the 300,000 equals 500,000. So right off the bat, I'm going to divide both sides by 300,000.
Well,
Does everybody agree if I take 500,000 divided by 300,000, I have a whole lot of zeros that drop out? There we go. So now, subtract 1. So 0.6e to the 4k equals 5/3 minus 1, which is 2/3.
Hey, Mr.
And then you divide everything by 0.6. Yes, sir.
Is there a formula for this?
It's given to you in the problem. How do you get rid of an e?
Back in law.
So whatever that nasty looking thing is give you your answer as you go through typing it in the calculator. Yes, sir. I think there was another part of this one. Let me finish that one real quick and I'll come back to it. Okay, hold on. Yeah, what?
What happens to 0.6?
It's 2/3 divided by 0.6. So it's the natural log of whatever 2/3 divided by 0.6 is, and then I hit enter, then I divide that again by 4 and go from there. Okay. So this value of k is going to take that, and then I have to figure out, estimate the sales in the year 2008. So I just resubstitute in that value of k in with a t value now of 8 into the model it gave me. Does that make sense, Jeff?
yes.
You're just going back now.
I got a negative.
Can someone say what they got? Oh, okay. So wait, we're gonna do that? Yes.
So I got a k value of 0.026, and then B, it's asking you, what is it, how many did they sell in 2008? So you're using that value of k that you just found, where k was equal to 0.026, and now your t value is 8. 8 is substitute back into the original model. So 500. From the problem, estimate sales in 2008, T0 is 2000. To be honest with you guys, this is about as tricky as some of these things get when you have to figure out how much time has elapsed and things like that. I'm getting sales figure of about 287,566.
Yeah.
Maybe they should start advertising more again. It might be worth it, unless it's a real crappy tool set. Or it was too well made and no one needed to rebuy it.
Did that happen?
Yeah, there's stuff that's really. I mean, think about what is it, the 1994 or 1996 Camry. There's what 90% of them are still on the road today, or somewhere around there. Like a year 2000 Camry, some of that model line. There's most of them, like more than. It's got to be more than 80% of them are still on the road. So I don't know why you're driving around a 15-year-old car, but hey, it still works. Why get rid of it? Yeah. Knock on wood, it's like my wife's car. 10-year-old Jetta, still runs. You diesel in it, it goes.
Is it 2009?
Math is strong with you. What else? Miles, you were saying what one? 65. Yes, sir.
The way the rock just shines.
We have to do 65.
Oh, we didn't have to do it? Okay.
Really?
I don't remember what it looked like though, just in case it was something similar.
It's like 1.4, 2, 4, 7. You can
Yeah.
fix it too.
Ah,
Right, I'm gonna look down.
I got a picture of all four, so I'm so happy about it. There you go.
Oh, it's just a matter of substituting in. Really, the total interest paid, you have your rate at 7.5%, so 0.075, and then they're saying that the P value is 120, and then T would be the total years. So you're just looking at time and substituting in. You're just looking at a table if you have to figure something out when it goes down to 0. You know, you're looking for a 0 in the calculator. That's just. I don't think that one wasn't assigned, but it's just a matter of can you look at a table set and figure out where it gets equal to 0. Okay. What else you got in that grouping from last night? Anything in particular? Yes, sir. 51? Yeah. The Richter scale. Yeah, someone else was asking me about this one.
Oh, that was me.
That's what I thought. So when they're talking about this intensity of the Richter scale, let's see. The I sub O is 1. Oh, I cut out the model. Oops. Sorry. All you're doing here is taking the log of, what is it? 1 over, oh sorry, not 1. I over 1 equals R. So the intensity is what we're solving for here. So 7.9 equals the log of I. What's the base? 10. So how do you get rid of the log? You 10 it. And you go from there. Okay. So it's the log base 10. We don't see it, so you'll have, so your answer would be 10 to the 7.9. And that works for all of them. Yeah. What's that? Yeah. What's that? Yeah, I'm just gonna go through some of those review ones here and start, or go back to the original page where I had them written down. All right, so review stuff. Looking at the review stuff, starting at, what is it, 11 through 14? Okay. 11 through 14 on the review. Let's see if I can. 11 through 14, can you tell me what happened to the graphs? When things get moved, we added an h value. If it's 5 to the x, then all of a sudden it's 5 to the x minus 1. What way did the graph move?
To the right.
To the right. X's and H's move horizontally. The K's were.
No, I know, I thought it was minus 1 was
Oh, you probably didn't see it because I was probably saying either way.
I see it, I see it.
Right. X to the X minus 1.
Okay, then, yeah.
Otherwise, I say X to the, or 5 to the X, all minus 1. So then it was all minus 1 in the direction. So yeah, graph stuff, can you tell which way they're moving? Pretty straightforward. Remember that when you're working with exponents, an exponential graph like that, 5 to the X, what are the values of X that you could pick rather easily to decide where your points are going to go? 0. 5 to the 0 is what? 1. And then 5 to the 1 is 5. What's 5 to the negative 1? 1/5. Good. So it's just those kind of values. You're going to use very easy numbers to make your lives happy. Okay.
Wait. What are you talking about?
Next. 2326. Let's see here. 2326. Of course, I have to move this instead of not one. I'm starting to not like the idea that scan each page individually. I'd be here forever. Could you solve these? Oh boy, I hope you can solve these.
Honestly, the first thing that threw me off at first, but then I looked at my note card because I wrote example down.
Well, they say solve using this nice, easy one-to-one property. You want to get the same bases. All right. Also, would be. This would be what? How do I rewrite 1/9 as a base 3? 3 to the negative 2. Okay, so this would be 3 to the x plus 2 equals 3 to the negative 2. In this case, since you have the same base, what happens to the exponents?
They drop.
They drop. So x plus 2 equals negative 2. X is? Hey! It's been so long.
I know, I felt like I was lost.
Been so long I hardly knew the place. Gee, it's good to be back in town.
Something like that. We'll go with that.
Do we have to do any more of those?
More. Pick the hardest one up.
Okay. 1/3 to the x minus 2. Oops. Equals 81. What's going to be the common base between a 1/3 and an 81? 3. Okay, I'm going to go out on the limb and just assume you're just saying something to say something. Please say that's true.
Yes.
Okay. Because could it be a 2?
No, I knew it wasn't. I looked at the 2 and I was thinking of. I mean, I looked at the 3 and I was thinking 2.
I'm just
and then I
harassing
said
you.
3.
81 is what? Is 3 to what power? Very good. 1/3 is 3 to what power? Negative 1. So this is 3 to the negative 1 times the x minus 2 equals 3 to the 4. Distribute your negative 1 to both those exponents, and then you set it equal to 4. Yes, sir.
Doesn't the checker
Yes, sir. I'll give you the chapter 4 one. See what you remember.
Not that.
So wait, X is
I don't know. I haven't done that. Yes. Okay. What's next? 35. What 35? Why did I pick 35 by itself? Oh no. I don't know if I remember how to do it continuously properly. So let's see. 35. Compound interest, which means I probably should want to make sure I know what the compound interest formula is. Don't you agree?
I agree.
E equals R.
You're forgetting something there.
My battery is actually.
So if I'm doing compounding once, twice, 3 times. What? Compound interest versus continuously compounding interest. Make sure I didn't write that down. I do believe it is. When to use what? If it says you're compounding continuously, perfect. Because you want to continuously keep the dandruff out of your hair. Because hurt is a dandruff shampoo.
I was like, how do you know that?
Wait, why though? Why is that?
Because that's the form that's continuous. What happens was E, this value of E, arises from this as n gets larger. As you do 1 plus r to the n, as it gets larger and larger and larger, it's approaching this value of E, the 2 point something or another. This is the one for number of times it's compounding, like semi-annually, quarterly, monthly. So you have sometimes it's going to compound. It's going to compound once, twice, 4, 12. That's when you use this. If it's continuous, because there's no n. It's green, isn't it? Yeah. It was in one of the Manhattan. Like I said, it was in the Manhattan Project. Matthew Broderick, Ali Sheedy, they hacked computers to change their grades. He tried to build a thermonuclear bomb, and there was the bad guy from Howard the Duck was in it.
The Mighty Ducks.
There's one.
So here's just a matter of substituting it and going for it.
There's a part that's.
If I do this one here for 4, and it's a matter of substituting it.
Wait, I have a question.
Questions on that? We okay between the difference?
Yeah.
I saw you dipping over there, didn't know if you were trying to see it. Got it? All right. What number was it?
39.
39. The next grouping, 39.
Not A, I already did that.
On the day a person is born, a deposit of 50 grand is made into a trust fund that pays 8.75% interest compounding continuously. Gee, I want that.
What number is
I'm gonna
that?
get to 39.
Wow. So then, yeah, if you were trying to figure out when it doubles, then you just have, you're setting it equal to,
I didn't know what to do after you divided by 2. I didn't know what to put.
oh, we're not divided by,
Well, no, you do. Like,
oh, I see what you're saying, okay. So, total amount would be 50 grand. It's compounding continuously, so it's E to the rate of 0.0875, and they're trying to do it for 35 years. That gives you the amount after 35 years. They're asking how long would it take it to double, so you set it equal to 100,000. It's too many zeros.
7.9.
Very off.
I answered my own.
Yeah, and when you're doubling stuff, it's basically you're getting rid of that P value and the A value, and the A value becomes 2. Okay, so what if we double? So is it 49 through 52? What do we have there? Again, solving equations with logarithms, using the ideas of the properties of what they call one-to-one. Oops. So on 49, do they have the same base? If they have the same base, what do you do? They just drop. Your answer is 7. Okay. Some of those are pretty nice. The weird ones, I think, with this happened when we had the properties mixed in. Let's see, did we have one like that? Thought we did. Expanding, condensing, because I know it's in this, right about in this spot as well. Remember, if you're gonna expand and condense, I think you had to do, I think there's one like that in 81. It's another one. If you want to expand this, so you've got log base 3 of 6 minus log base 3 of the cube root of x. But what do I rewrite the cube root as? Excuse me. X to 1/3, and where does the power go then? To the front of the thing. So it would be 1/3 log base 3 of x. Okay. Remember some of those how you pull those things back. I don't believe that was a very difficult thing for most of you guys. Equations, man, you guys are equations are easy. Yes, ma'am.
Wouldn't it be the test as easy as it should?
No. What is it?
That's the end amount. What are you going to end up with after X amount of time? I want to jump ahead because here's one where you deal with properties. Look at 127. 127 says this. Log base 8 of x minus 1 equals log base 8 x minus 2 minus log base 8 x plus 2.
Oh, yeah, got it.
We gotta, we gotta condense. You gotta condense before you can get rid of the
What
logs.
number is this?
127 is? Yeah. So what I would do here is that you know that you're gonna get the log base 8 of x minus 1 is the log base 8 x minus 2 x plus 2. Now when you 8 it to both sides, the exponentiate, the logs drop, they roll away.
I
gotta use up all my log jokes before we're gone with this.
Okay. I'll allow it.
Absolutely. And then you wind up with fraction equal fraction, therefore you cross multiply, and you're gonna get, this goes away, x squared plus x minus 2, subtract x, add 2, set it equal to 0, and we get x squared equals 0. X is 0. So we just got to check, make sure it would work. Can we take a log of a negative?
No.
No solution. It's extraneous, if you will.
Because there's a solution.
It's an answer,
Wait,
but
what's
it's not an answer. But it's not an answer. Very good. 127.
I couldn't comprehend that last year. I was going to be an answer, but it's not.
No. Going back and trying to graph logarithms, remember log base 7 of x. If I want to graph logarithm, I want to pick those very easy one-to-one properties. I'm going to plot the idea of log base 7 of 7, which is 1, and log base 7 of 1 is 0. That gives me the two ordered pairs that I need to work. Logarithms, remember they're increasing going from right, left to right, go through like that. It's just a matter of plotting out those 2 points to make it work. Okay. If you go back, that's in 3, I think? 3, 4.
So then the points would be 7 and 1 and 1 and 0, right?
Yeah. Yeah, they talk about how you do those quick graphs with the logs is in 3-2, excuse me. And it basically built off of those two ordered pairs. By picking the same base, and then you pick log base whatever 1. Okay? Yes, sir?
What does it say natural log?
Same idea. If it's a natural log, then you think of it as log base e.
Oh.
Okay? And then you just go through that. And e, log base e of e is 1, so e was what, 2 point something, so you just kind of guesstimated in your dial on that.
If they're gonna wait,
What? I don't know.
do we have to find the x-intercept and the vertical axis?
Well, you could. Isn't your x-intercept?
Oh.
when you're trying to find your x-intercept, isn't that going to be in here? Yes.
When the log base and the base is the same, and like, why does the exponent
It's called exponentiating. What happens when you solve stuff out, if you have that log base 4 of x, and that equals the log base 4 of 2. What happens here, since this is what they call that one-to-one property, to undo a log, we raise it to that power. So that way you've got a base here raised to a log with the same base. It's called exponentiation. I don't think it's really called exponentiation, I just kind of call it that. That's how the logs go away.
Well, like the log base, the numbers are the same, but the numbers like they can do a power, or does the power zero?
Oh, it's why does the power drop? Because what happens is if it was, all right, log base 3 of 3 squared. What's the power rule for the exponent? It goes out in front, doesn't it? So this is the same idea of log of 2 times the log base 3 of 3. What's the log base 3 of 3? 1. That's why that works. Does that make sense? What's up?
Okay, so on my note card I wrote, so log base a x times h plus k, and then says x equals h equals x. So since log base 7x there is no h, that means first fraction equals 0.
Yeah.
Okay.
Yeah.
And then can you say subtract, please?
Same deal, natural log of x.
So I need
When you graph the natural log and stuff, you do the same idea where natural log is the same thing as log base e of x. All right. Now e, if I'm not mistaken, is 2.1-ish in that neighborhood. So if I say if I want to pick values, if I check it at e.
So would we need a calculator to do this, or?
No, you're using the real simple properties. Log base e of e is 1. So at e, it'd be up at 4. Okay? It's that kind of idea. And just remember that e is approximately 2 and change. Okay? You're still using the exact same ideas of those properties to go with that. Does that make a little bit more sense there? Yes, sir.
Can you do 86 and 94?
86. So let's see, natural log of a whole bunch of junk. And they put in the thing, it's got to be greater than 1. So first thing you do is move the exponent out. Then we have the natural log. You wind up with that. So you break that apart then. And that's about it. Okay. Then you have, that's why they have it as y has got to be greater than 1, because if it was 0, you can't take it. So that's why they're putting that little extra piece in there, right? You won't have to worry about that. If there's something like that, it'll give you that little parameter. It's just saying, in order for this problem to work, it has to be greater than 1. Does that make sense? What was the other one? 93? 94? 94, that's just going backwards then. In 94, you've got the 1/2 natural log of the junk. Oh, -1, excuse me. Then it's -2 times the natural log of some other junk. So this tells me that I've got the numerator has a square root. The reason that it has a square root is because it's got a half power. So the numerator is going to be the natural log of the square root of 2x minus 1. That's being divided by the quantity x plus 1 squared. Okay? Oh, I'm sorry, that was 93. I'm sorry, that was 93. No wonder why you're probably looking at me like crazy. Sorry, that's 93. All right, I'll rewrite that. So it's 5 natural log. Oh, I see why you're asking about this one. Okay. Same basic idea. You're getting a complex fraction.
What would you multiply the last?
You get natural log of the quantity x minus 2 to the 5th over x plus 2 all over x cubed. That's really all it is. It's a complex fraction. Now I know why you're like, well, yeah, the other one was easy. It's nothing crazy. Which one? Whatever. Yeah, because for the first 1, 2, 4, 12, 3, 6, 5, you have, because that's the number of times you're. That's correct. Because you want to continuously keep the data population. Is it this one? No, keep going. I had to condense the left hand, the right hand side first, and then I wanted it before I could get rid of the logs. Sometimes we had problems every once in a while where you had to condense before you can simplify. And then you got fraction equal fraction possible pi. I did have my sheet.
Come on.
What's that? Might not be that. Yeah, the answer. You got x equals 0, but 0 won't work because you substituted 0. Can you take a log of a negative? That's why it's a straight pass. So it's an answer, but it's not an answer.
So,
I would say no solution.
Mine, I don't know.